Hello, everyone, and welcome back for a quick demo here on a example that I call the date calculator, which is sometimes different than the last example that we did, which involved the hypothetical student budget. In this case, we're not talking about calculating the cost of taking your significant other out on a date for Valentine's Day or some other special occasion, but rather we want to do math with dates, which is not something that most people have thought all that much about when they're at this point. And so I opened up a blank spreadsheet. For those of you that are in my class, I added a second tab to my workbook. You could also start with this blank file and simply do that. I've named the tab Date Calculator just to identify it, and I've typed in text up here that says Date Calculator, and it might appear relatively large. It's still 11-point font, but I've blown up the screen here to 150% so you can see things a little bit more clearly. And in Excel, there's a function that they introduce in our textbook that we might use, and they use it fairly commonly. We might want to know, well, what is today's date? So I'm going to type in the text, today's date, make that column C a little bit bigger. And when we deal with dates, I could enter today's date. It is January 30th, 2025. I could type in 1/30/2025. It would accept it. If I came back tomorrow, it would say 1/30/25. If I came back next year, it would say the same thing. Entering a date is the same as entering a number. It stays as a constant. And there are times when we want that. I ordered this item on this date. I shipped this order to a customer on this date. We received a payment from the customer on this date. There are plenty of things in business where we want to record the actual date and keep it as is. But there are other instances in spreadsheets or documents we'll create using spreadsheets where we want it to automatically put in the correct date. We don't want the user to have to think about what is today's date or how, enter in the incorrect date. We don't want them to enter in a date in the past, intentionally or unintentionally. And so I've got this cell, and I'm going to have the cell D4 contain today's date. And one way to do that is through a function that is aptly named equals today. And the today function, you need to open and close parentheses. There are no arguments in the syntax. There's no cells we're referring to. There's no other syntax that's needed. And if I hit enter, it will say 1/30/2025. Again, come back tomorrow, it will say January 31st. Come back the day after, it's February 1st. And so with that function, which again is underneath the hood, I see 1/30/2025. I have to double click to see the underlying calculation, in this case, the today function in that cell. And so that's a useful tool. But if I want to do math with dates, I might say, and I'm going to use a very generic uh, phrase here, but you might say date in the past. You could do this with your birthday is a date in the past. Certainly, it could be an anniversary date. You started a relationship. It could be a date that is important to you. But the idea is you put in that label. Again, that's text. I'm going to now type in a date without using a function. I'm going to just enter in a constant value. And so I might put 901 um, 2002. So I'm going to pick a date in the past, which was a start of a full-time teaching job. And so in this particular case, we've got this date in the past, 9/1/2002. Again, if that was your hire date and we have today's date, HR or other parts of a company might want to know, well, how long have you been employed, or how old are you, or how many years have you been a member of this organization? Whatever the question might be, again, that involves some date in the past and today's date. And with those two values, or with any two date values, I can do math. And so I could say equals, and I could take today's date as a cell reference, D4, and I could subtract the date in the past, D6. I'm doing subtraction. And when I hit enter, it is going to do a calculation and it's going to come back with 8,187. And that is the calculation. Again, you might wonder, what is that number? That's certainly not how old, how many years old are you? What it is the number of days. And so in that span, if you started work on September 1st, 2002, and today is January 30th, you've been employed by that company for 8,187 days. Or if that was your birth date, you're 8,187 days old. You know, People don't typically walk around asking you how many days old you are, but now you have an ability to calculate it. And if it's near a nice round number, you might have a reason to have a celebration. Maybe you're near your 8,000th day on this earth, or maybe you're near 7,500, or whatever that number might be for you. Again, days is one measure of time. If I said I want to know how many years it's been, I could convert that number. Number of days is a useful value, but there are 365 days in a year, 365 and a quarter if I want to count leap years. And so I could say, well, let's do some calculation and say equals that number divided by 365.25. And if I do that, I'm going to get the age. In this case, somebody who was born on September 1st, 2002 is 22.41478 years old. And again, we don't run around talking about our age in years with decimals very much. Typically, if you ask this person, they'd probably say, I'm 22 years old. I'll be 23 in September. But there are times where we might want to know or calculate what is that value to a specific value, specific accuracy. In Excel, when I calculate it, it's showing 5 decimal places. There is the ability to format on the home ribbon or in the format toolbox to increase or decrease that decimal. So, I could have it show tenths of a year and say, well, this person's 22.4. And if I change the date in the past, if I said, well, this person was born on August 25th, 1997, they're 27 years old. And when I change that value for the date in the past, it will change the corresponding calculations. And so we have this automatic updating like we saw in the budget example, except that now we're changing a date and the math calculations automatically adjust. And so, there will be times in places where calculating differences in days becomes important. And Excel has a number of other functions. In the textbook, eventually we'll talk about a function called net work days, where it calculates the number of working days instead of the number of calendar days. This subtraction is counting all the days of the week, where there might be times where we want to know, well, how many actual work days were there between these dates? And we want to omit Saturday and Sunday as weekends. And also, there's an option in that to omit holidays. And so if you're trying to figure out, you have to pay a supplier, to show up on Monday through Friday, how many days are there in this time period? Again, there's a function called network days that we'll eventually get to. But for the time being, we can do math with dates, and it's pretty simple. It's the same as the subtraction of two numbers. And it's partly related to the idea of the way Excel handles dates. Again, you can format dates a lot of different ways. So if I right click and go to format on that first cell D4, when I go into the number format, we're in the date category. All of these are ways that I could have the appearance of that date. So I want month and date. Do I want the month, date, year? Do I want the year first and then the month and the date? Do I want it to say March, or have the month spelled out with the date and the 4-digit year? There's all kinds of variations. So again, underneath the hood, they're still referring to the same calendar date. They're just variations in how you display that. And so calculating with dates is pretty simple. The other thing that I want to add into this example as an extension, because calculating dates is interesting. It's useful. But the thing that is very useful that comes in for our textbook eventually is the idea of logic functions, in that we don't only want Excel to calculate things automatically, put in a new date and or update the date, and it will calculate the new number of days, number of years. We want it to do some thinking. And thinking and having Excel make its own decisions involves some logic functions. And so in chapter 3 of our textbook, we are going to learn the very first logic function. Actually, there's two logic functions. We're only going to use one in this particular example, and we'll cover the other one in the next video. But these logic functions are ways of giving Excel, the spreadsheet, some ways to handle and think through a situation. And so, again, we're all familiar with logic. We may not necessarily be so accustomed to writing it down and then telling Excel in the right language or syntax how to do it. And the first logic function we're going to use is something called the if then else statement. And if you've done some computer programming, you've certainly seen this. It's a very often a starting point to the idea of doing some programming. But an if then else statement is to say, well, if this is true, then I want you to do this. If it's not true, then we want you to do something else. And so again, you can use that logic. You can say, well, I'm approaching an intersection. There's a pedestrian in the road. I'm going to stop. If I'm approaching the intersection, there's not a pedestrian. I don't need to stop at that unmarked intersection. Again, we do this all the time with various things. We learn it when we're young, so it's not unfamiliar, but it does take some time to think through, well, how do I tell Excel to do this? And when we have logic functions, there's another term that I'm going to introduce that's not necessarily in the textbook, but it's something that is certainly very true. Our textbook tends to be very much technical, and we certainly are applying the technology in business situations. And so I'm going to have a note over on the side for business rules, and for this case, it's going to be pretty simple. But in business rules, these are rules or considerations that companies come up with, and I sometimes separate them from legal rules. Again, there are some rules that are set up by the government, and so if you're interested to vote and you want to know, well, am I eligible? If you're 16 years old, by the U.S. Government rules and laws, you are not eligible to vote. You have to be 18 years of age as a minimum age to vote. And then there are other considerations or requirements that go along with that. But businesses make rules too that are not necessarily laws. They are choices. Again, when you get hired as an employee, the company has a choice of how many days of vacation to offer you, whether to offer you vacation, whether to offer you insurance or profit sharing. Again, there are some kind of industry slash norms, but again, it's not necessarily always mandated by law. And so, in this case, we might want to know the answer to a question. And I'm going to pick something that is not based on law, but there are some car companies out there that if you went to the airport or you went to the car rental agency, they would tell you that you have to be 25 years of age or older to rent a car. Now, they may have reasons for that, and they might say, well, people who are younger than 25 but have a driver's license may not be responsible, or we want to avoid bad experiences we've had in the past, whatever the reason might be. But certainly, a business can say you have to be 25 years of age to rent a car. And so in this particular case, we might have a spreadsheet where we enter in a date in the past, somebody's birth date. We have today's date, and we want to know, are they eligible to rent a car or not? And so I'm going to add a space to my spreadsheet. Again, the text gets a little bit lengthy, so I'm going to widen out column C. And in cell D12, I want to write a logic function that will evaluate, look at the calculation of number of years and make a decision and respond with an answer. And in this particular case, the answer is either going to be yes or no. And certainly that's the case in lots of customer-facing things. In other cases, the resulting answer could be different numbers. It might be the price is different if you're over 25 versus 25. Some companies do that. When you go to the movies, again, if you buy an adult ticket versus a child ticket, there's a difference in price based on your age. And so the value of true and the value of false in this calculation, in our case, will be words, but it could be numbers or it could be a separate calculation. And so we'll get to those things later on. Chapter 3 is sort of the warm up for logic functions. And the logic function syntax is easy to remember. There is a function called equals if, and I open the parentheses, and this is the first function we have now where there's a little bit more syntax. You'll see there's a little tooltip that shows up that says logical test, value of true, value of false. And in those three slots separated by commas, we have to enter in the information to tell Excel what we want it to do. And so if I say, well, we've got years calculated in cell D10, and our business rule that I wrote off to the side is that D10 has to be greater than or equal to 25. We have to translate 25 plus, or some people will say 25 years or older. Again, if you're exactly equal to 25 on your 25th birthday, you are eligible. Again, that endpoint, is it equal or greater than only by itself, is up to the person creating the rules. I put a comma and it asked me for the value if true. And if it was a number, I would type just the number. In this case, it's the word yes. And so when I use text as a return for this argument, I need to put it in quotation marks. And it's easy to forget that after after you make the mistake one or two times, it'll come back to you. But we need the word yes in quotation marks if that logical test is true. And if it's false, we're going to say no. And when I close the parentheses and hit enter, Excel will evaluate cell D10 and respond with an answer. It says no. We know, thinking through this ourselves, we could know that 22.4 years age is going to get rejected. But the idea is not to say, well, I could think through this in my head and I'm going to just type in the answer. We're going to run into situations relatively quickly where we'll have, say, hundreds or thousands or hundreds of thousands of entries, and each one might have its own birth date, and we want to respond, with a logic function, yes or no. I don't want to have to sit there and go through each individual one and think it through and type in the right answer, even though I could, but that's brute force. We want to type it in a way where we can type that once, and just like we did in the budget example, copy it down and fill all the way down to the bottom. And if I change the date in the past, so I said, well, what if I pick somebody again, you're born 8/25, 1998, that puts you at 26 years of age, and the spreadsheet comes back and says, yes, you're eligible to rent a car. And so we have this syntax that allows us to ask a question with the logical test and then specify what is the answer if it's true and what is the answer if it's false. And so that is our first logic function, the if function. Typically in a SAM activity, they're going to specify what they want and how the order of that logical test will be. If you think about it long enough, you might realize you could rewrite that syntax, and you could say, well, if D10 is less than 25, I could ask, are you under 25? And if the answer is true, the answer for the value of true argument would be no. We would reverse the no and the yes. And that, distinction, do I ask the question, are you 25 or older? True and false mean different things. If I ask, are you under the age of 25? true and false mean different things. And so, when we start doing some non-SAM activities, you have to think about, well, how am I asking the question and what is the resulting meaning of true and false? And you might do it one way and your neighbor does it another way. And when we get to later chapters, I think it's chapter 7, we get into more advanced logic functions. One of those advancements is the ability to ask a series of questions, what we call nested if functions. And so in that particular case, it becomes even more important to think through in your mind, what is the first question I'm going to ask? What does it mean if you're, true or false? Then what's the second question I would ask? What's the value of true and false? Because if you're asking the questions in different uh, uh, orders, you could end up, with a very different set of syntax than somebody who does it a different way. And so, again, SAM is always looking for a single answer, so they're going to be very specific. But when you're not using SAM, you're doing this on your own. You can do it the way that you think through the problem, and as long as you're consistently thinking the same way throughout the problem, you'll do okay. It's where you start thinking one way and then you change your way of thinking halfway through that things get mixed up. And so, with that, I will sign off and we will see you soon. The next video will be on a couple of financial functions. Have a great day.